Hi! This practice exercise is concerned now on determination of the values of the variables x, y, and z upon looking at the relationship that could be drawn from angles formed by a transversal. I'm talking about the angles formed here and here. Why do we concern with these two angles here? Now, the first answer for that is that number one is requesting us to solve for the value of x, and these two angles here has that value. Second, we cannot assume any relationship first with any of these two and any of the remaining angles here, because we might end up with an equation having two variables. So that's our goal. We need to come up with an equation. But how? We are given already that the line E and F are parallel lines. In short, line T is a transversal cutting parallel lines. And with that, we can use the postulate and theorem supporting the relationships of their measurements. We do have five because we have five pairs or angle pairs, or pairs of angles formed by a transversal line. But these two angles here are forming which pair? So that's our first consideration. So we need to identify whether these two pairs here are forming corresponding angles, alternate interior, alternate exterior, same side interior, or same side exterior. As you can see, both angles are now found on the interior part of this given figure. That would mean scrap the corresponding angles postulate, that would mean scrap the corresponding angles as it needs one to be in the exterior on the exterior. Scrap the same side exterior and scrap the alternate exterior. So these two angles now are forming either alternate interior angles or same side interior angles. But as you can see, they are found on the same side of a transversal line. So if we use the term same side, that would mean that these two angles are forming same side interior angles. Now that we are sure that they are forming same side, they are forming a pair of same side interior angles, we can use here the same side interior angle theorem. This is only possible with this claim here. So if this claim here is not present, we cannot use this, and that's it. We end our video, we end our practice exercise. There's nothing more that we can do. But then again, we do have in the given here that the lines cut by the transversal line are parallel lines. So we could use the same side interior angle theorem, which tells us that if a transversal line cuts two parallel lines, the same side interior angles are supplementary. Let me repeat. You also have it in your module in other references. Again, if a transversal line cuts two parallel lines, then the same side interior angles are supplementary. They are not congruent, not be confused with the alternate interior. If we talk about same side interior angles in a parallel line, they are supplementary. If we say supplementary, that would mean that if we add their measurements, we have x plus 11 degrees plus the x minus 11 degrees. They must sum up to 180 degrees because that is what the term supplementary is telling us. So unlike the equation formed in the previous practice exercise wherein we just simply equate the measurements of two angles, here we cannot do that because the same side interior angle theorem does not tell us that they are congruent. Rather, it tells us that they are supplementary. So we have this um, equation, add the two measurements, must sum up to 180 degrees. And if we have this, simply apply the properties of equality. X plus x, that is actually 2x. 11 minus 11, that's 0, is equal to 180 degrees. And then divide both sides by 2. We will have x is equal to 90 degrees. So this should be the value of the variable x. But let us check it first. So we could you apply here checking. Using the given equation here and substituting the value for x, you will have 90 degrees plus 11 degrees plus 90 degrees minus 11 degrees must be equal to question mark 180 degrees, for they are actually considered to be supplementary. And then when we sum this up, 90 plus 90, this is actually 0. So I have here 180 degrees is equal to 180 degrees. Now we are sure that the value for x that we have solved out from these relationships and the equation given is correct. The other form of checking for this is by giving the value for the unknown angles. So if we have x plus 11 degrees, where x is a 90-degree angle, we end up with 101 degrees. As for x minus 11 degrees, where x is 90, that's degrees, that's 9, and then you have 7. So you have 79 degrees. I mentioned that this is a form of a checking because if we are going to sum these two, it must yield 180 degrees, as it is the claim of this theorem that the angles must be supplementary. So 101 plus 79, that's 180 degrees. Another checking for the value of x. So we have two checking here, but this is very important, this second checking, as this is actually very beneficial for solving the rest of the items. So now that we have here the variable y, let's look at the angle y, or the angle with variable y, and pick any angle with the variable x. Do not use z here, and you might say corresponding angle, sir, because you will just end up with an equation having two variables. I'm talking about this and this angle here. So still we are going to use the previous angle pairs we have learned in the previous lessons. Okay. So as for these two angles, they are actually forming vertical angles. And by vertical angle theorem, all vertical angles should be congruent. Congruent or have the same measurement. So if they have the same measurement, equal lang po sila. So we just simply equate y, this one here, is equal to the value of the angle here, which is x plus 11 degrees. As this is actually solvable, because we already have the value for x here, we can always substitute here the value of x, which is 90 degrees. Or better yet, you already have solved earlier the value for x plus 11 degrees, which actually 101 degrees. Simply substitute the whole quantity, y is equal to 101 degrees. This is what happens for item number 2, because we already have here the solution here. Definitely, you could always use the value of x and then later on still get 101 degrees. That's up to you. But since I already added this one, I will be using this. As for the value for angle z, or the variable z, this angle here, we could always use again that they are corresponding angles with angle y. But if we have slight error in computation for angle y, it might be a problem for solving angle z also. So to avoid that, let's use this angle and this angle here having the variable x. And they are forming a linear pair. And by linear pair postulate, we need to make sure that the sum of their measurements must be equal to 180 degrees, since the linear pair postulate tells us that angles forming a linear pair are supplementary. So if we're going to sum them up, z plus x minus 11 degrees must become 180 degrees by linear pair postulate. X minus 11 is already given to be 17 degrees. You would always use x, but since we do have this, let me use this. Z plus 79 degrees must be equal to 180 degrees. And then simply apply the subtraction property of equality. You will get a value for z, which is 101 degrees, which could actually be related to the angle pair formed by angle y and angle z. They are corresponding angles, and since we do have parallel lines here, so we could apply the corresponding angles postulate, which tells us that the corresponding angles are also congruent. As you can see, they have the same value. We just did not use that relationship earlier. We used the linear pair postulate because again, we need to avoid a mistake of a slight error, a possible error that could that have may have committed in solving the value for y. What if you mistakenly use 100 and you will use corresponding angles postulate? You will also say this as 100, so this is also become incorrect. Okay? This is what happens when two angles are forming a pair of same side interior angles. So again, this is made possible by the claim that they are the lines cut by transversal line are parallel lines. So please look for other references, other examples, or you may contact me if you have problems and you could practice more on these types of problems. Simply need to remember the relationships for the angle pairs formed by transversal line, especially when they are parallel lines, and then also use the concepts of previous angle pairs, specifically the vertical angles in a linear pair or angles forming a linear pair. Thank you very much for watching. We still have one more video soon. Goodbye.